Hello everyone. In this video, we will see how to install Anuta ATOM on AWS Cloud in a multi-availability zone HA cluster. ATOM supports deployment across multiple sites to support high availability in the event of a site failure. This requires ATOM components to be deployed across multiple sites or availability zones. In this video, we will first start with the setup creation on AWS Elastic Kubernetes service across multiple availability zones. We will then see how we can deploy ATOM in a resilient HA setup on the same AWS-based Kubernetes cluster. Let us now start with the Kubernetes cluster creation on AWS Cloud. One of the prerequisites include installing EKSCTL. We already have it installed in the machine. We are now on the AWS console and we can see here that there are no clusters created at this time. Back on the terminal, we will start with the cluster creation. In the command used, you can see the cluster name, other related parameters, along with the different availability zones that we have chosen within the region for the cluster creation. Once the command is successfully executed, we can see that a new cluster has been created and is active. The same can be verified on the terminal as well. Then we update the kubeconfig file for the new cluster that we would like to access. The next step is bringing up a set of Kubernetes worker nodes on the cluster that was created. As you can see here, we do not have any worker nodes created yet. The same can be verified on the AWS console as well. But before we add the worker nodes, it is important to move to the CNI plugin that is recommended for ATOM installation. For this, remove the default plugin and install Calico, which is a recommended plugin. It is now time to bring up a 6 worker node setup where we'll finally perform a ATOM Resilient HA deployment. In the commands used here, apart from the node specific parameters, please note the node zones that point to a particular availability zone and also the node labels to handle the placement of different ATOM components. You can see that one of the nodes have been created and the same can be verified on the AWS console as well. Similarly, other 5 nodes are also created across the 3 different availability zones. As seen here, we now have 6 node Kubernetes cluster created, and we'll also use the same setup to bring up an ATOM in a resilient mode. The next step is to install an ATOM instance in a resilient HA mode on the 6 worker node Kubernetes cluster that we just created on AWS. This is the spec of the HA setup that is already taken care on the AWS. Here are the software requirements for deployment. The deployment images for ATOM are stored in the software repository Quay. The deployment package for installation will be provided by Anuta. The package will have Helm charts and the corresponding YAML files that will take care of the default configurations for each of the microservices in ATOM. It will also have the details of the images that needs to be downloaded. Unzip the atom_deployment zip file and edit the wrapper.properties file. In the deployment section, ensure that the build number is set to the correct release. The deployment is set to AWS the size is set to resilient, the software repository is set to QA, and the organization is set to release. Also ensure that the atom.log in the var log path has all the permissions. We are now ready to start the installation of Atom. Execute the deploy_atom script to start the installation. We can see that Atom is successfully deployed. Here we can see that different pods in Atom are installed in different computes that are spread across different availability zones. This shows that Atom instance can be installed on a multi-availability zone cluster. Now that Atom is installed, it is time to enable connectivity to the local network. Here we assume that AWS site-to-site VPN configurations such as customer gateway, virtual private gateway are already created. Attach the already created virtual private gateway to your VPC. As you can see, the virtual private gateway is now attached to the VPC. What we also need to do is to propagate the route tables to enable the traffic through the connection. This operation is performed for all the nodes that are part of the Kubernetes cluster. Our next step is to allow all the traffic on the security groups to enable seamless communication between the Atom instance and the devices on your local network. We are now ready to access the Atom instance. We can access the Atom UI using the external IP or the URL of the load balancer service. Apply and activate the license on the license screen and continue to Atom's UI. As you can see, we have now logged into Atom with the default credentials. In Atom, we have two replicas for the front-end pods, and as seen here, both the pods are on different availability zones. For the resiliency test, we will stop the compute nodes carrying one of the front-end pods as shown here. As seen here, one of the existing front-end pods are terminated and new front-end pods are getting created. As seen here, we are still able to access the UI without any issues. Let's also add a device to see how that works. And we can see that the device has come online on Atom. This shows the resiliency of Atom when deployed in a HA setup. So in this video, we discussed how Anuta Atom can be deployed in a resilient mode in a multi-availability zone AWS Kubernetes cluster. Thanks for watching.